Canoe slalom is a summer Olympic sport where a single canoeist must navigate flowing rapids downstream through a series of gates. These gates must be passed in a certain direction, requiring the canoeist to paddle upstream as well as downstream. Canoe slalom was introduced as an Olympic sport in 1992.
My name's Lado, I'm doing biology.
My name's Eunice, I'm doing ESS.
My name is Megan, I'm doing chem.
My name's Lily, I'm doing biology too.
My name's Alistair and I'm doing physics.
Gravity is an important force in canoe slalom because it pulls the water and the canoeist down the sloped riverbed. And in the canoe slalom, because we have gates that go in both directions, the canoeist has to cross the flow of the water at times, which means that the force of the water is pushing the boat this way, and if you have the desired trajectory here, you have to paddle across so that your resultant vector will achieve your required destination. The canoeist will transfer the chemical energy in their body into kinetic energy through their muscles and the paddle, and then they will use that to push themselves and the canoe in any direction.
Kevlar canoes are used in canoe slaloming because of the strength of Kevlar. Kevlar is made up of thin sheets stacked on top of each other. Kevlar has both intermolecular, which is between molecules, and intramolecular, which is within a molecule, hydrogen bonds. There are nitrogen-hydrogen bonds within the molecule, which makes it have strong intramolecular forces, and then there are oxygen-hydrogen bonds connecting the molecules, which contributes to its intermolecular strength. Additionally, it has strong London dispersion forces. London dispersion forces are dipole-dipole attractions that happen for brief moments of time as electron clouds shift. This strength is because of the large size of the electron cloud, decreasing attraction between the electrons in the nucleus, making it easier for them to be polarized. This polarization increases the strength of attraction between atoms and therefore the intermolecular strength. The strength of Kevlar makes it ideal for canoe slaloming because it would be very bad if the canoe broke mid-race because of the intensity of the sport.
Training for canoe slalom involves both frequent endurance and resistance exercise, leading to changes in aerobic and anaerobic metabolic pathways over time. Chronic endurance helps promote aerobic processes by increasing the body's oxidative metabolism. Oxidative fibers produce ATP through aerobic pathways using oxygen, and more ATP is produced each cycle. Endurance also promotes greater fuel diversity during exercise, with metabolites coming from carbohydrate, amino acid, and fatty acid metabolisms, as opposed to only using carb substrates. On the other hand, chronic resistance training increases glycolytic metabolism to improve the body's anaerobic capacity and muscular fitness. Resistance exercise induces elevated protein synthesis and depletion of amino acids required to increase muscle mass. It also activates the pathways involved in nucleotide synthesis to produce DNA, RNA, and phospholipids for the cell membrane. Since anaerobic exercise exhausts the body's ATP stores, muscles resort to ATP regeneration through the breakdown of glycogen. This activity also increases the accumulation of lactate produced by the glycolytic fibers.
Canoe slalom is a fast-paced sport, only lasts about 100 seconds before it's over. This means that it is incredibly strenuous on muscles. More muscle strain means the heart needs to pump more oxygen throughout the body. Observations of cardiovascular stress during slalom canoeing, peak and mean heart rates are reported to be 184 plus or minus 8 and 173 plus or minus 14 beats per minute. On average, 20-year-olds' max heart rate is 200 BPM. A normal active heart rate is 100 to 170 beats per minute, which is about 50 to 75% of your max heart rate. When you go above that, from 170 to 200 beats per minute, that's 90% to 100% of your max heart rate. And then you reach VO2 max. This is the maximum oxygen consumption attainable during physical exercise. When your heart rate approaches its maximum, your body starts burning more carbohydrates and protein for energy than fat.
Some unsustainable aspects of canoe slalom are that they use artificial waves and the lakes are man-made, so they disrupt habitat for a lot of species living in the area. Artificial rivers lead to loss of habitat, trapped sediment, and damaged species. Overall environmental issues with the Olympics are an extreme amount of carbon emissions, There is an estimated 395,000 metric tons of carbon emissions involved in traveling to the Paris Olympics. There is an overall estimated 1.58 million tons of CO2 emissions. Some mitigation strategies are that the Paris Olympic Committee are trying to use 100% renewable energy. Also, 95% of their infrastructure is going to be buildings that already existed, so they don't have to build new buildings. They are also trying to decrease carbon emissions to make travel time shorter. They've done this by making 80% of the events within 10 kilometers of the Olympic Village. As you can see in the model, the Paris Olympic 2024 model is different from past Olympics, and they're trying to decrease carbon emissions significantly compared to previous Olympics.
Representations of forces and energy help us understand how difficult the sport is.
Knowledge of the inter and intramolecular forces in Kevlar helps us understand why it's the right fit for canoe slaloming.
Under the right conditions, the metabolic adaptations that occur from endurance and resistance training can provide benefits for aerobic capacity and muscular strength, which is really important in canoe slalom.
The Olympics are a major sporting event, but there are also a lot of environmental impacts you have to consider when going to the Olympics.